Good morning, students. So, let us start with today's class. So, we will be discussing about the single phase cycloconverters, step-down cycloconverter with RL load today. So, as of now, we have already covered the single phase step-up cycloconverters, single phase step-down cycloconverter with R load. Today we will discuss the single phase step-down this cycloconverter with RL load, means the inductive load, right? So now, so let us start with the topic. So the first is the midpoint type cycloconverter, step-down cycloconverter. And in our yesterday's lecture also, we have discussed that how a step-down cycloconverter works and why is it called as a step-down cycloconverter, right? So I'll repeat this one. So step-down means where the output frequency of the signal is less than the input frequency Fs, right? So okay, so sorry. So let us see what happens with in case of RL load. So the circuit diagram which you could see on your screen is related to step down cycloconverter, midpoint type step down cycloconverter with RL load. So here you can see there are 4 SCRs used, and the center tap of the transformer is connected with the load, and the positive directions of load current and load voltage are given here. So in this type of cycloconverter, the thyristor T1 and thyristor T3 belong to the positive group of SCRs, because these two SCRs would conduct for the positive cycle, right? So for the they would give you the output as the positive envelope of the supply. So for the and similarly T2 and T4, these two SCRs are considered in negative group of SCRs, because the output voltage and current because of these two SCRs would be negative, right? So for the positive half cycle, SCR T1 and SCR T4 will be forward biased, because for positive half cycle, Vs, so the positive half cycle, this point will be positive A and B will be negative. So in this case, this particular SCR is forward biased and this particular SCR is reverse biased, right? So similarly here also, this SCR is reverse biased, you can see, and this SCR is forward biased, right? So that means T1 and T4 are forward biased. So, but we will not conduct them or trigger them simultaneously. So let us see what happens. So there are two things that we'll discuss here, because now inductor is being used in this case. Inductor has been used here in load. So obviously the nature of the current will change. So there may be a possibility that the load current could be continuous in nature or load current could be discontinuous in nature. So in case of resistive load, this condition does not take place, because in a resistive load, the load voltage and load current both are in same phase, and that is why there is no question of continuous or discontinuous current. But in RL load, so because of the presence of inductance, there is always a lag between current and voltage, wherein the current lags the voltage by some angle. Okay, so now let us study this one. So a whole story has been mentioned here. If you would go through these points, so the points have been summarized here, right? So let us understand the working through the waveforms. So this waveform, the very first is of supply voltage, then we have load voltage, and then we have load current, right? Now you can see that the supply voltage is pure sinusoidal, right? This is one cycle, complete one cycle for input voltage, and then this one is the second cycle. So the output that we are getting here, you can see the load voltage, it is shown with dashed lines here. So this is the output voltage. That means for two complete cycles of input supply, we are getting one cycle of output voltage. So that means here the output voltage, output signal frequency F naught is half of S, half of Fs, right? So no, so the working is totally similar in this case also. The only difference is that the current, the nature of current would be different, and we would be seeing the effect of inductance on the output voltage and output current, and we will see that how the current is lagging and its effect is observed in the output waveforms. Now you can see that from this waveform, so you can see from this waveform V0, you have triggered the SCR T1. Now if I go back to the circuit diagram, if we go back to the circuit diagram here, so for positive half cycle of the input supply, this is forward biased and T4 is also forward biased, but we do not trigger T4 as we do it in step up cycloconverter. So for the positive half cycle, only T1 is triggered. Then to get the positive output, right? Then for the negative half cycle, sorry, for the negative half cycle, this end is negative and this end is positive. So this would make this SCR reverse biased, right? And this SCR forward biased. Again, you can see this SCR will be forward biased because its anode is connected with the positive, right? And this will be reverse biased because its cathode is connected with the positive. So for the negative half cycle, we do not since we have two SCRs which are forward biased, this SCR T2 and this SCR T1. But we do not trigger T2 in this case. We will only trigger T3 so that we can get the positive output. Sorry. So now, so let us come with the positive half cycle first. This is positive, this is negative, T1 is forward biased, T4 is forward biased, but we do not trigger T4. So let us see if we trigger T1 at omega t is equal to alpha for the positive half cycle, how the current will flow. The current would flow like this. So you can see that the direction of current in this case is same as that of the reference direction marked on the circuit diagram, and hence the output voltage will also be positive, right? So now, so for the negative half cycle, if you see, for the negative half cycle, okay, I'll check why it is happening. This would be positive and this will be negative. So here this SCR will conduct. So the current will flow like this. So in this also you can see the output current is similar to that of the reference markings of current and voltage. So similar is the case of for the T2 and T4. So let us come back to the output waveforms here. So you can see for this first positive half cycle of first cycle, T1 is conducted and you will get this kind of response. In our yesterday's experiment also, if you remember, by varying the value of inductance, we could see its effect on the output. So you can see at omega t is equal to pi here, your output voltage is 0. Output voltage is 0, but output current is not 0. You can see output current is having certain value, right? It has certain value. Okay. Sorry. So similarly for the negative half cycle here, you can see for the negative half cycle where T3 and T2 are forward biased. So T3 is made to conduct to get the positive response. Okay. And you will get some output also in current. Similarly, for the negative groups, T4 and T2 are conducted simultaneously for positive and negative half cycle of second cycle respectively. Right now you can see here that at omega t is equal to pi, your output voltage is becoming 0, but load current is not 0 because of the inductance. So the load current will take some time to dissipate through SCRs, conducting SCRs. So it will become 0 at some angle beta, which we generally call as extinction angle. So as soon as you can see beta has arisen, so you have this voltage is also 0. So now the output voltage has become 0, but here you can see at beta, this is beta, to alpha, your output voltage is 0. Why? Because from omega t to alpha, from omega t pi, from omega t is equal to pi to omega t is equal to, so ये जो 2 pi plus alpha लिखा है, it is not, it is pi plus alpha actually. So this is all typos. So now, So at this pi from omega t is equal to beta, यहाँ से बीटा से लेकर to omega t is equal to 2 pi pi plus alpha तक you don't have any output voltage. So since you don't have any output voltage, why it is so? Because you're conducting SCR. Then let us come back to the circuit diagram. T1 was conducting. So at omega t is equal to beta, T2 will turn off, T1 will turn off, right? T1 will turn off, but you have not also triggered the next SCR, which is to be triggered. Okay, for negative half cycle, which SCR is to be triggered? T3. T3. Okay, so T3 is to be triggered, right? But since at omega t is equal to beta, T1 is turned off, T3 is not triggered. So that means your complete circuit is off. All the SCRs are open now. Okay, so in that case, no current will flow through load. So that means the current will become discontinuous. So you can see at beta, the current has become 0. So it will remain 0 till you trigger the next SCR T3, let us say. So as soon as you trigger the T3, so it will go and increase, and then it will become like this. So you can see in case of resistive load, you would see the current waveform is similar to that of voltage waveform, right? Like this. Okay, there is a sharp edge here, and then like, but here you can see it is totally round shape. Okay, so this is the discontinuous nature of the current, and it is because of the inductance present in this one. But that same inductance is also responsible for the continuous nature of current. Now that means inductance is present in both cases, discontinuous mode as well as continuous mode. But the only difference is that in case of discontinuous mode, the value of inductance is quite small, and when we increase the value of inductance, the nature of the current, load current, will become continuous. In our yesterday's experiment also, we have observed this thing, that when we increase the value of inductance, its effect was observed on the load current, which became continuous. So sorry. So the whole story has been mentioned here. You can go through it, right? So okay, now let us come to the continuous load current. So in case of continuous load current, this is supply voltage. The circuit diagram will remain same. Midpoint cycloconverter. The circuit diagram will remain same. So in case of continuous load current, you can see. So the SCR T1 is triggered at omega t is equal to alpha here, and output voltage will go to 0 at omega t is equal to pi, you can see. But at omega t is equal to pi, load current is not 0. So it will dissipate till some duration. Okay, and by that duration, your output voltage will become negative. Okay, output voltage will become negative, right? Now, why the output voltage becomes negative, that also you can understand from the inductor. Because let us say load is resistive and inductive also. So RL load is there, right? So let us say this is A end of load and this is B end of load. So actually we are taking the positive voltage as this plus and minus V naught, right? Okay, but when omega t pi is reached by the supply voltage and negative half cycle starts, so what will happen? The SCR, the conducting SCR, which one was conducting? T1. It will become reverse biased because of the negative half cycle. You can see negative half cycle. Now this reverse bias, it will become reverse biased, but the inductor which is present has current stored in it. So it will start dissipating or releasing its current through the conducting SCR. Okay. Your T1 has become reverse biased, but it will keep on conducting because of the inductor. Right, one thing. Second thing is you have not triggered the next SCR T3. Okay, So the current that would be released by inductor only has path through T1 only, right? So now this end will become positive in this case and this end will become negative. So this thing, because now your inductor is behaving as the source, kind of source, and because of which the current is flowing, right? And this voltage negative of the inductor will make your conducting will keep your conducting SCR in conduction mode for short duration, right? So the current would start releasing and it will flow through the circuitry, right? But your conducting SCR T1 is because under the effect of negative voltage. So this negative voltage would suppress the anode current, forward current. So hence your current is reducing here. It is not increasing, it is reducing. And because of this reducing current, because of, because this current will reduce to a certain value and ultimately at some duration of omega t, some value of omega t, your SCR T1 will be turned off. Now this negative voltage which will appear here for that duration for which your load current is dissipating during negative half cycle when T1 is reverse biased, this will appear because of this nature, this thing, plus, minus and plus. So that means the voltage here across this inductor would overcome the effect of this plus and minus, the actual reference direction. Now for the next half cycle, negative half cycle, T3 will be forward biased. You can come to the here. T3 is forward biased for negative half cycle and T2 is also forward biased. But T2 will not be conducted because it is negative group of negative SCR, means SCR from the negative group. And T3 is the SCR from positive group. So we need the positive output. So for T3 you will get the same kind of response, right? This one. Now, as soon as your one complete cycle is over, for the next complete cycle, the positive half cycle, for the positive half cycle, you will make to conduct T4. Now let us come to the circuit diagram. You can see for the next positive half cycle, the upper end will be positive, lower end will be negative. So this SCR is forward biased. T1 is also forward biased, but you will not conduct T1 because it is SCR from positive group. Now you need a negative supply, negative output at the load. So you will trigger T4 for that. So you'll see, you'll get a negative response here. And similarly for T2. Then again next cycle will come and like this. But your current will remain continuous. So as soon as your T3 will conduct, so again your current will start from that very value जहाँ पे वो minimum हुआ था. वहीं से it will start and reach to a certain value. So you can see at omega t is equal to pi here. Your load current is not zero. It is at certain significant value. Right? So now because for the next cycle you have triggered T4. Okay. So the current will reduce to zero and increase in the negative direction. Start increasing in the negative direction. And then hence for that particular circuit also will get a continuous current. So in this way, because of the inductance only, because of its value, low value and high value, we will either get the continuous load current or discontinuous load current. Now, so this circuit, this waveform which is shown here belongs to the midpoint type cycloconverter. Now let us see in case of bridge type cycloconverter with RL load. Now the working of this particular cycloconverter is similar as that of R load, is the working which we studied in bridge type single phase bridge type cycloconverter with R load. Okay, here the SCRs will operate in pair. So for positive half cycle, you can see T1 and T2 from positive group of SCR will conduct, and S3 and S1 and S2 from the negative group of SCR will conduct. For the negative half cycle, T3 and T4 will conduct, and here S4 and S3 will conduct. So this one is for positive half cycle HC, positive half cycle. This is also for positive half cycle of main supply, and this one is for negative half cycle of the main supply. Similarly, this one is for negative half cycle of main supply, right? But then they are made to conduct in some sequence so that we can get the positive and negative responses. So you'll get the similar kind of response when you will make them conduct, means you will make these SCRs conduct, right? Here the notations are used properly. So earlier when I was discussing the notation here, 2 pi plus alpha was written, that is a typo. So please ignore that. So here you can say the response is totally same, but the only difference is that the SCRs are conducting in pair. SCRs are conducting in pair, right? So the whole story has been written here. So similarly for the continuous load current also in bridge type cycloconverter, you'll get the similar type of response. You can see that why it is step down transformer, because this is one complete cycle of output waveform. So to get this complete cycle, you have used 2 cycles of the main supply, right? Now it all depends upon the triggering of SCRs. It all depends upon triggering of SCRs, right? You may, like in this case, if I talk about this particular case here, F naught is equal to 1 by 2 Fs. Now why have we got 1 by 2 Fs? Because for the first cycle of input, we have triggered 2 SCRs. Then for next cycle, 2 SCRs from positive group. Then for next cycle of input supply, we have triggered the 2 SCRs from negative group, right? Now for example, just imagine now, so for example, if I would conduct, for let us say for this particular cycle, I am conducting the SCRs from the positive group. You can see T1, T2, T3, T4 all belong to positive group of SCRs. Let us say instead of triggering the SCRs from negative group from next cycle also, what I will do is I will conduct all these 4 SCRs once again. I will conduct all these 4 SCRs once again. Just imagine this one. So let me draw the waveform. So my drawing is very poor. Just please forgive me for this. So let us say there are 2 cycles, for example, right? So now let us say this is pi and this is 2 pi. I hope you all are getting this thing. This is 3 pi and this is 4 pi, right? Now, for example, for the first cycle, I am conducting the SCRs of positive group, right? So for the second cycle, earlier, I was conducting the SCRs from negative group. Now let us say I'll conduct the SCR from positive group only. So what type of output I'll get? I'll get something like this. Let us say for resistive load. For convenience, we'll consider resistive load, right? So what is this? The average value. Now let us find out its average output. So its average output is like this. So that means this is output voltage and this is supply voltage Vs, right? So this is omega T, right? So now can you see, for 2 complete cycles of input, you have got half cycle of output. For 2 complete cycle of input, you have got half cycle of output. Now that means, let us say for next 2 cycles, you would conduct the SCRs from negative group. So that means one complete of cycle of output. One complete cycle of output is equal to 1/4 of, or you can say, for getting one complete cycle in the output, you are using 4 cycles of input. So that means F0 is equal to 1/4
1/4 Fs.
Fs. Very good.
Fs.
So 1/4 Fs. So this is how. That means the output frequency and the input frequency. From here it is clear that this is step down transfer, cycloconverter, but the value of output frequency all depends upon whether it is half of Fs, whether it is 1/4 of Fs, whether it is 1/6 of Fs, 1/8 of Fs, or whatever, right? So that totally depends upon how you trigger the positive and negative SCRs. Okay, so if I have to get 1/6 Fs, so in that case what I will do, I will keep on triggering the positive group of SCRs continuously for first 3 cycles of input, then for next 3 cycles of input supply I will continuously conduct the negative SCRs. So from 6 cycles of input you will get 1 cycle of output. So that means F0 will be 1/6 Fs. So this is how you can vary the value of output frequency just by switching the SCRs in a proper sequence, right? So this is the story is written here. You can see, you can go through it. Whatever I have explained to you verbally, everything is written here. So tomorrow we will start with the 3-phase to single phase cycloconverters. This is our tomorrow's topic. So for today's lecture, this is it. So if you have any question, guys, you're most welcome. Gauri, have you understood the concept?
Yes, sir.
Okay, thank you so much. So then I'll call off the class. Thank you, guys.